Think about how a newspaper subscription works. A publisher prints the paper, and copies are delivered directly to the subscribers. If you want the news, you get on the list. Move away, you take your name off. In software design, the publisher is the subject. It holds the data. The subscribers are the observers. They wait for the subject to tell them when data changes. Consider a physical weather station. A central weather data object receives sensor readings and updates 3 distinct user displays: current conditions, weather statistics, and a forecast. Usually, you might write a method that calls an update function on each directly. But if we need to add a 4th display for a heat index, we have to open up and modify our core weather data class. Hard-coding these calls creates tight coupling. When the list changes, the core logic must be rewritten. This leaves the system rigid and prone to errors whenever the requirements expand. We solve this with an interface. We create a subject interface for registering, removing, and notifying observers. Next, we define an observer interface with an update method. This establishes a one-to-many relationship. The subject is the source of truth, and observers are dependents. Under this design, the subject doesn't need to know what the observers actually do with the data. It only needs to know that every object on its list implements the observer interface. In the code, our weather data class implements the subject interface, using a list to track observers. The current conditions display implements the observer interface, registering itself. When measurements change, the subject loops through its list, triggering the update method on every registered observer, passing the new values. This allows objects to interact while remaining independent. You can add new displays to the system without changing the subject's code, as long as those new displays adhere to the interface. There are 2 ways to move data, a push or a pull model. In the push model, the subject sends all its data through the update method. In the pull model, the update method takes no parameters. Instead, the observer uses getter methods to request only specific data it needs. Let's apply this. Pause the video and write the pseudocode for a new forecast display using the pull model. To implement this, the forecast class implements the observer interface. Inside its update method, it calls a getter on the weather data object to pull the temperature. The pull model shifts the responsibility of data selection to the observers. If the subject adds new types of weather data later, your existing observers won't need their method signatures changed. Java includes a built-in implementation in the java.util package, but observable is a class, not an interface. Since Java forbids multiple inheritance, if your class inherits from a GUI component, it cannot also extend observable. This makes it difficult to follow the design principle of favoring composition over inheritance. Building your own interfaces avoids this restriction and keeps your objects flexible. To summarize, the observer pattern creates a one-to-many relationship. The subject acts as the state owner, and the observers act as listeners. By using interfaces, we achieve loose coupling. The observer pattern replaces hard-coded updates with a structure that handles change automatically. By separating the data from the displays, you create a system that can adapt as your requirements grow.